Here's the problem that sold me on taking moments about a point other than the center of gravity. So here a strut AC can withstand a maximum compression force of 150 pounds. We have to find the maximum acceleration of the cart up a 30-degree incline so that strut doesn't fail. Now, a free body diagram of the crate and the platform. Let's first use moments about the center of gravity, g. The crate weighs 150 pounds, so we put the gravity force through the center of gravity, g. FAC is the strut force that makes an angle of 60 degrees with the horizontal. Let's see other forces. There's a pin connection at B, which is going to give us forces Bx and By. If we just apply Newton's laws, sum of the forces in the x direction equals m times the acceleration of g in the x direction. We're going to get force FAC cos 60, it's the horizontal component, minus Bx is going to be equal to, turns out to be 4.66 Ag cos 30, because the acceleration of g cos 30 is the x component of g's acceleration. And 4.66 is the mass of this crate in slugs. Alright, so let's see, there's 1, 2, 3 unknowns in that equation. Call that equation 1. Sum of the forces in the y direction, m, a, g in the y direction. We'll have the vertical component of force AC. We'll have By going up. We'll have 150 going down, and that's going to be MA. But now we're looking for the vertical component of AG. So we have 1, 2, 3 unknowns there. Of course, you may be thinking, okay, FAC, we're going to set FAC to 150 pounds because that's the maximum force that it can withstand. So really, we have unknowns Bx, Ag, and By. So that'll be equation 2. Sum of the moments about G will be 0 because this thing is it is translating. So we'll have FAC cos 60. Horizontal component of FAC has a moment arm of 1 foot. Okay, so FAC cos 60 times 1. Let's see, the vertical component of FAC is going to give us a clockwise moment, so we'll have FAC, this thing keeps slowing down on me, minus FAC, come on, okay, there it is, minus FAC sine 60 times 1. Bx and By both create moments about g. Bx is clockwise. We'll have minus Bx times 1. And we'll have plus By times 2. And all that equals 0. So that'll be equation 3. So once we set FAC equal to 150, so we set FAC equal to 150 pounds. We have 3 equations, and we have 3 unknowns, which we can do, but it's a bit of a pain. And it's a bit of a pain because Bx and By create moments. Now, if we take the moments about point B, Bx and By are not going to show up in our equation. What we want here is the acceleration. Alright, so free body diagram of the crate and the platform again. But this time, we are going to take some of the moments about B. What Hibbeler would say is some of the moments about B is equal to the sum of the kinetic moments about B. What I'd rather do is I'd rather draw in the inertial forces. So we have acceleration of G at an angle of 30 degrees up the incline. So I'm going to resolve that into an inertial force m agx and another inertial force m agy. I'm going to have a moment arm about B for the x component of 1 foot. I'm going to have a moment arm for the y component about B of magy times 2 feet. Now when I take moments about B, what am I going to get? I'm going to get a moment due to the gravity force, 150 pounds times 2 feet, that's clockwise. If I split FAC into horizontal and vertical components, only the vertical component, which is FAC sine 60, that'll give me a moment which is equal to force times a distance of 2 plus 1 is 3 feet. And that moment is going to be clockwise, so that's minus. My x inertial force, that's going to create a clockwise moment, so I'm going to have plus m. My agx is going to be, well, before I said my mass was 4.66, so I'll throw that in there. Agx is ag cos 30. So that's the inertial force. And I said the moment arm was 1 foot. So I'll multiply that by 1. The y inertial force will give me another counterclockwise moment about B. So I'll tack on 4.66 times ag sine 30 times a moment arm of 2 feet. Okay, so those are the sum of the moments about B, including those due to the inertial force. And all those are going to be equal to Ig alpha, but here alpha is 0. Okay, so let's look at this equation. What do I have? I have one equation. When I set FAC equal to 150 pounds, how many unknowns do I have? AG. That's it. I can solve this equation directly. So I can solve one equation directly for AG. And if I do that, if you punch in all the numbers there, you'll get AG is equal to 10.3 feet per second squared. Okay, so here we saved a lot of work by taking moments about an arbitrary point B, which had a lot of forces going through it. By taking the moments about that point, we ended up cutting down on the number of moments that we had. Alright, so because I said before I don't really like the terminology that Hibbeler uses, here I wrote the equation that you'll see in Hibbeler's solution. I'm going to take that and I'm going to move it up, and I'm going to write the equation that I want. And the equation that I want is sum of the moments about B including due to inertial force equals IG alpha. All right. So there you go. Both these documents from these movies will be posted, and we'll discuss an example along these lines in the next lecture. Thank you.